it's booting, it has that blue bar going across.
Mhm.
So it takes about another 10, 12 seconds. Oh, almost. Oh, yeah. We should be live. I'm going to click that again because it didn't. No, it's going. You're live, guys.
All right, thanks, Steve. So welcome to this session. Today we're going to talk about safety training for educators that are either coming out of a pre-service program or transitioning into technology and engineering education. So I'll introduce myself first. I'm Mark Harrell. I'm the director for the STEM Center with ITEA, overseeing all of our programming as far as curriculum, teacher professional development, research, and several other things that we do. My background, I was a TSA state advisor. Prior to this role, I have 12 years in the classroom, engineering technology education, worked for another STEM curriculum nonprofit company for 3 years. And then I spent about 8 years at the Department of Ed doing program consulting. And I'm also joined with Tyler Love. I'll let Tyler introduce himself.
Hi, everyone. So I'm at University of Maryland Eastern Shore. I run our CTE, alternative licensure, work-based learning and career counseling certificate programs, and our bachelor's in technology and engineering ed. My office is here on the Inner Harbor in Baltimore. For a number of years, I wrote the Safety Spotlight articles with a number of authors that were in the ITA journal. I was on the NSTA, National Science Teaching Association Safety Advisory Board for a number of years. I have my OSHA trainer credentials for general industry. And in 2017, I was recognized as ACTE's Career Safety Educator Year.
Yeah, great. So Tyler and I have worked together for years in my previous role, like I mentioned, with the Kentucky Department of Education. And just to give you some data on why we decided to do a safety workshop in Kentucky, and then we're going to show you some results and then also go into some things that you need to consider if you're transitioning into technology and engineering, either for the first time or coming back into the profession. So as you may know, and this is a Kentucky statistic, but it's pretty standard across the board nowadays where the vast majority of our teachers are not credentialed in industrial technology or technology education anymore. When we pulled this data in Kentucky, 24% of our middle school and high school teachers were credentialed from a pre-service program in industrial technology or technology education. But you can see 34% of our teachers were science ed certified, 32% during this data poll were math certified. We had 7% occupation based, and that's when alternative certification, like Tyler was saying, that he oversees, where maybe an engineer or a technician comes out of the field and then becomes an educator kind of through some other means rather than a traditional post-secondary program. And then we had some miscellaneous in there as well. This could be emergency certified. It could be long-term subs, a variety of ways that teachers can get into the classroom using some alt-cert programs as well. Tyler, you want to go over this, just the findings and from the larger data set?
Sure. So if you haven't checked out ITEA's safety website, it's a great resource. On there, you'll find a number of state reports. So Kentucky is on there. We didn't put all the states, only the states where we had a decent sample size. And if state directors requested their state samples. So you'll find some reports specific to some states on there. And then you also find the free ebook from ITA and also the free safety test that when students submit them, it grades them and submits an email to the instructor. So there's a lot of good resources on there. And this is kind of where that data came from in terms of Kentucky, but there's also other states on there for you to check out.
Yeah, and if we have time at the end of this presentation, we can pull that up and just kind of walk you through those resources too. So yeah, in 2020, we did a national safety survey, and Tyler, I may have you speak to this holistically, and then I can kind of give the Kentucky piece to it, if that's good.
Sure. So we had, we sent it out through ITA and the state associations, and we had 718 responses from people who were delivering technology and engineering education in 42 different states. And so there's probably 15 or so articles that have come out from this where we looked at the data in different ways. And some of those articles will be discussed in this presentation. But in terms of Kentucky, we had 44 participants, and the Kentucky sample was kind of interesting because it was that high population or high sample of alternative out of content teachers. Whereas in states like Pennsylvania, we had more traditionally trained teachers. So there were findings from both of those where we could look at differences between teachers' backgrounds, experiences, and how they related to safety, which provided for some nice findings and recommendations.
Yeah, so here you can just see when we pulled out just the Kentucky data, just to give you an idea of one of these states that were involved. You can see 43% of our respondents were female, 98% were white. And then you can see nationally at the bottom, 74%. So we actually had a higher female population fill out the survey than the national. And then, but you can see our ethnic background was a little bit different than the national data as well. Anything you want to add on that, Tyler, on this slide?
Nope.
So here again, this is just showing the data that teachers inputted into the survey. And this kind of mirrors what I talked about earlier as far as like science ed seems to be one of the primary areas in Kentucky that teachers are coming into STEM or technology education. Whereas the national level you can see is heavily career and technical education through the lens of technology and engineering was at 78%. And then the interesting thing I found on both the national and the elementary, and I guess it depends on who the survey went to, is the elementary folks that identified as STEM and technology education. So we had 5 teachers in Kentucky fill that out, 3% at the national level identified as elementary teachers. And so it's great to have their feedback on this as well. So some of that feedback that we got, just looking at both the national, but also the Kentucky landscape, primarily the teachers had 16 to 25 years of experience. It looks like both at the national level. It looks like in Kentucky, they were either brand new or new career teachers, 4 to 8 years that provided feedback, or the 16 to 25 years of experience. And then you can see at the national level, primarily it was actually the older population, the teachers, the seasoned teachers that filled out the survey. 51% of them were 16 years and up as far as years of experience. So that kind of provides a different a slant on the survey as well.
Mark, one thing I'll add is that
Yeah.
in related to that last slide, in the years of teaching category, one of the interesting things we found from the large national sample safety results that we published was, surprisingly, we didn't expect to find this, but years of teaching experience really did not have an effect on the safety factor. It really came down to safety training was a big one. Occupancy load was another one. Number of students in your class that have a disability and how many instructors were involved to help. So it was more about the quality of the preparation, the quality of the help, and other factors, more than just how many years was someone teaching. And I think that says a lot about what we're presenting, is that, just because someone's been in a classroom for a while, accidents still unfortunately do occur. But what are those specific factors that make a difference? And if we know those, which we've identified in the research, can we help make sure that those safety factors are in place and we're addressing those to give those people a better chance at keeping things safer?
Yeah, that makes sense for sure. And we'll kind of go into some of the recommendations towards the end of some of those things that came out of the study, and then even the training that we ran in Kentucky that were kind of just best practices to help teachers. Here again, you can just see by grade level how the survey broke down, and Kentucky's at the top there, whereas the national survey respondents are all at the bottom. But primarily middle school and high school teachers filled out the survey. Some teachers identified from K all the way through 12. Maybe they were in a small rural district where they had kindergarten through 12th grade students, but the vast majority of the respondents were at the middle school and high school level. And then kind of getting into some of the feedback as we pull the data out of the survey. And Tyler, maybe I'll let you go into this slide just to talk about the bar graph here.
So we asked a couple questions. It was a long survey, so thank you if anyone is attending that filled it out. We asked teachers, do you have a PPE policy in your school district or your school system? And so in Kentucky, 41% said yes, 32% were unsure. That should be 100%, right? Every school district should have a policy on PPE. Unfortunately, due to COVID, I think PPE is now a more well-known acronym. But PPE in terms of safety glasses and everything should be something that every school district has. We also asked, has your district conducted inventory of chemicals? That was down. And does your district have records or reports of injuries that occurred within the last 5 years? And so a lot of people weren't sure about that. As you see the purple there on the graph on the very end, a lot of people were unsure if they had any of that. So all those fed into some of the recommendations that we made, but it was interesting to see from a district level and then department level and even classroom level, the differences in the policies that were in place.
Yeah, so here's some of the recommendations that came out of that survey. Obviously, work with your school district. Hopefully, they've identified a safety compliance officer, legal counsel, your fire marshal of your local community is a great resource as well. Obviously, administrators and supervisors, and then other teachers maybe that are in a similar program in your district or a neighboring district or even in your own school. But there really should be a written safety program in place that includes protocols, inspections, training, follow-ups, lab inspections, et cetera. Work with your Board of Ed to help develop that written safety policy. That's probably going to go through a legal counsel as well, just to make sure that you're covered and that you've done your part as an educator in the classroom. Ask the questions about PPE, like Tyler mentioned, chemical hygiene, safe disposal of chemicals. You may have a chemical hygiene officer or safety officer that understands how to safely dispose of chemicals or how to store them safely in your classroom. Refer to legal resources. OSHA is a great resource, NFPA, and other professionals such as ourselves at ITA. NSTA has a lot of resources as well. And then everything has to be consistent and fair as far as safety. Safety is it knows no gender, it knows no background, doesn't know if a kid's on free and reduced lunch. It's just consistent and needs to be safe across the board. Anything to add there?
One thing I'll add, Mark, is that like in Maryland, we just released the new safety guide for science education. And in that guide, it talks about using engineering tools and power equipment for engineering design because of NGSS. So although it's a science ed resource out of our science ed department, it will apply to tech ed teachers and even some CTE teachers in absence of another guide that's more up to date. So I know that a lot of people in different states will say, well, it's just a guide, it's just recommendations, because like in Maryland, we're locally controlled. So the county school systems have a lot of power in making decisions, right? But the thing that you need to make sure is when you have these safety programs is that you're aligned with your state safety guidelines, and that should be like minimum, right? And then if your local policies don't meet the minimum of the state, you've got some issues. So you want to make sure that you're in alignment with state. And if you're in a federal OSHA state, you want to look at those with your safety resource officer in your school district. If you're under a state OSHA plan, then you want to make sure you're aligned with the state OSHA. OSHA really protects, is more geared toward the employees in the school systems. It doesn't really apply as much to students per se, but it will have an impact on them. So you just want to make sure that you're looking at your state guide and making sure things are aligned, because those will get pulled as something that gets reviewed by legal counsel if something were to happen.
Yep. Yeah, that's for sure. Yeah, then you can see here some states kind of take the OSHA, the federal OSHA standards, and kind of make them their own. Kentucky is an example that we've done that, but other states just adopt the federal rules verbatim, I think. Is that right, Tyler?
Yep, they're called by reference, federal by reference.
Yeah. So
And
then, yep, go ahead.
you can look that up on the OSHA website. There's a map and it'll tell you which states are state plans and which ones are federal by reference.
Yep. Yeah. So make sure you're just following all those regulations that are out there. They're just there to help you and try to make your lab a safe place for students. So jumping back to some of the survey, just to get some feedback from teachers. So again, Kentucky versus national, but you can see we asked teachers, did you receive any form of safety training? You can see their answers there. When you were initially hired, did your district provide any training? And that one's sadly not where it needs to be, both at the Kentucky level, but also the national level. That the vast majority, two-thirds are at the Kentucky or national level are really saying that their district did not provide any safety training before just turning them loose into their lab or into their shop.
And that's really important because like when I was teaching in Maryland K-12, I worked for 2 different school systems and I just come out of a traditional tech ed teacher prep program. So I had coursework on safety, and each school system made me go to their safety training day. And at the time I was like, why are they making me go to this? But when you think about it, every school system or every school district may have different policies and different contacts and what do you do in this situation, everything, right? So that's why that initial hiring safety training is not only important, but it's actually required under OSHA. So you're supposed to provide initial training to employees when hired for a position and when their teaching role changes. So if you were teaching like a tech ed class and then they asked you to teach a chemistry class for some reason, that would be a major change in your job duty and would require some serious safety training because you're going to encounter some different hazards.
Yep. Another question we asked on the survey, just to kind of paint this picture, is how long have you been since your district last offered a safety training? And you can see in Kentucky, sadly, 55% of the respondents had said their district had never offered a training, where at the national level it was a little bit less, but that number is still really high. One final question, then we'll move to some more recommendations. Have you participated in a safety training provided by someone other than your district? And you can see here, 7 of the respondents in Kentucky, or 16%, said yes, but 84% in Kentucky had said no. And then at the national level, the numbers are slightly higher. It's at 18% for the yeses, but still that's 82% of the teachers had not been to a safety training within the last 12 months. And so that's something that in Kentucky we really took note of when I was at the Department of Ed, and really started to put plans in place to make sure that these teachers had access to safety trainings that we offered with some partners such as Tyler and some other folks that would help us do that. You want to go through this one, Tyler, these recommendations?
Sure. So like I mentioned previously, federal OSHA, if you're under a state plan, it's going to be federal OSHA at a minimum plus probably more. Says safety training must be administered upon initial hire anytime a new hazard is introduced. So like a new chemical or something that you're working with, or a new machine, right? If it's a piece of equipment that you don't have and you're getting a new one. And again, change in teaching assignment, which I talked about. And again, OSHA is there to protect the employee, right? So if you get a new teaching assignment or you get a new hazard, you can request in writing to your school district or school system for information and for training. And by law, they're supposed to provide it to you. Make sure you keep documentation of that communication so you have it. Under duty or standard of care, the employer has a legal and professional responsibility to provide those trainings. And like I mentioned, you can request them in writing. Do we want to, Mark, do we want to take a pause for a second and see if there's any questions or anything that popped up from the host?
Sure. Yep. Can you do that on your side since I'm sharing the screen?
I am looking and I don't see any questions at this time.
Okay.
Found another notice.
Yeah, and if you do have questions, because this isn't a two-way communication platform we're using, pop those in the chat, and then Steve will relay those to us, and then we can answer those questions. But really, the reason we give these recommendations to educators or administrators or whoever may be watching this this session is to give you that fuel for the fire to go back to your district folks and say, hey, this needs to be done. We need to find, if you just got a new CNC plasma table, for example, OSHA's saying that you need to be trained on safety when it comes to that new piece of equipment. And so use this to your advantage to go and lobby for safety training, just to make sure that you're kind of covering your backside when it comes to safety in the classroom. So here's some other good feedback to use. Oh,
Mark, I see one question
okay.
I can see a chat, so I know you can't. They asked, is this data from a recent study or the one that was completed a few years back? So this is the one from the survey was sent out in 2020. The book was published in 2022. So, I mean, we just got done putting out all the articles, doing the statistical analyses. Eventually, at some point, we'll probably redo the survey and take the lessons that were learned from the first round of data. But you have to understand that science education had studies like this beforehand. If you look in the literature, tech ed, it's been a while, and we don't have a lot of data like this of recent. So this is kind of what I call the foundation, kind of building some of that. And then with statistical software packages and stuff now, I mean, we can do a lot more. So it'll get better. But again, you got to have something to start with. And so this is kind of helping us to build that knowledge and do better. So Ray, thanks for that question. And, I'm definitely interested in looking at this deeper when we get more time.
Yeah, great. So a couple more recommendations. When I was the program consultant in Kentucky, that one of the number one questions I got from teachers was, how many students are they allowed to put in my classroom or my lab or my shop? And I didn't have an answer for that because Kentucky doesn't have a regulation or a statute that goes into that. But a couple of things that I would point the teachers to is fire code when it comes to the NFPA 101. Life safety code requires 50 square feet per student, and that's net square footage, not gross. So you can't count the space underneath a workbench, and you can't count the space that lives underneath the 3D printer table or the computer lab desks. So it is net. And so one thing that I would tell teachers is have your students, as an exercise, calculate the net square footage of your lab, and then that will help you determine how many students can safely be in your lab or your shop. You can see research suggests a minimum of 16 square feet, but again, that's research based. It's not really a law or regulation. But again, this is all data that you can take back to your district and your school just to help make sure that you're conducting a safe classroom. And then we always recommend annual safety inspections. We actually have, I think, like a safety checklist out on our safety website, right, Tyler? And then so does NIOSH. What does that stand for?
NIOSH is the Institute of Occupational Safety and Health.
Okay, yeah. And again, that's something that your students could do as an exercise as well. And not that you're going to rely on their data only, but it's a good exercise for them to go around, check the guards on the machines, make sure the gap on your belt sander is at the right spacing, making sure the tools are all in working order and the cords aren't frayed, and just going through that exercise so they understand what they should be looking for when they're using your space as well. And then Tyler, I'll let you take the last 3 bullets just to split this slide.
Sure. So again, so there's 2 publications that are listed there. Both cite the page from the NFPA 2024 life safety code, and it explicitly says in there shops and labs. So I know people get kind of offended when the term shop is used, but that's the language that NFPA 101 uses, and that's what applies to tech ed and science, even makerspaces, right? Anywhere you're doing lab activities, it's still classified as a lab or shop in a school setting. And so that's where those come from. That's all cited in those articles. One is the laboratories one. The lower link is a like 4 or 5 page brief article that gives some examples of recent accidents in the literature, and then talks about how you can work with your administration and your school system and cites the fire code and all that. The top one is a really long article. I'm not going to lie. It has a lot of information in there, but if you read the abstract, it gives you pretty much what you need to know. And it says that in the study, from the data that we have here, we analyzed the Mid-Atlantic data, and we found that amongst 117 participants, those that had more than 24 students in their lab or in their class with one instructor, once you got above 24, the odds of an accident occurring increased 8 times. Once you got above 30, the odds of an accident increased 21 times. So if you want data to take back to your school system, to your state, and say, this is why occupancy load matters, in addition to NFPA 101 mentioning it, that's some pretty powerful data to go back and say, this is why occupancy load is important, and we can make things safer because the data is showing that as we get more students, right, it makes sense, it's common sense, but now that you have the data to support it, it's a little bit stronger case to make.
Yeah, and Tyler mentioned it earlier, but put it in writing, and that way you have a time stamp and a date stamp. So sadly, or something would happen, and lawyers get involved, which could definitely happen. You'd be able to refer back and say, well, in August of 2024, I sent you the fire code, and I sent you this research that shows that accidents increase based on the number of students. And so have a conversation for sure, but also put it in writing in an email. So you have that kind of time and date stamp to fall back on as well.
I'll say one other thing I'll add is that Maryland's new, it's actually online, Maryland's new science safety guide, and I can put the link in if anyone wants to see it. They actually made recommendations for occupancy load in labs based off of NSTA's research, which is from 2003. And then the study that we just did recently this year that mimics that. So that's a strong stance for state departments to make, because they normally try to stay away from that because it gets kind of controversial. But Maryland has put it in their safety guide. Here's what we recommend based on the research and based on the fire code in our state. And Pennsylvania also, in their draft, they're going to have a new safety guide coming out probably by the spring. It's currently being reviewed, and they also have information in there that's very similar. So if your state doesn't have it, there's 2 states that do include it in their guide, and there's research out there to suggest why it's important.
Yeah, so let's go through some classroom management recommendations that kind of came out of this work. Students should always be trained and tested and have some sort of safety acknowledgement that's probably signed by a parent or a guardian as well. And that's really for anything that involves a hazard, and that could be hand tools, power tools, hot glue guns, anything that could be hazardous for students, and not just the hands-on side of things, but the chemical side of things as well. Like Tyler, I think on that last slide, it mentioned like use non-lead solder and make sure your ventilation is good. And honestly, that's coming into play now with 3D printers. Like there's been more and more talk about as the 3D printers are heating up and melting that plastic, the fumes coming off of those 3D printers, whether it's PLA or ABS, and then the resin printers, especially nowadays that are printing in resin. You can never be too safe when it comes to the ventilation side of that. Students should have safety glasses, and those safety glasses should have side shields. And then again, when we're working with chemicals, they should be vented chemical splash goggles for liquid hazards. So think about that. And that may play into resin 3D printers as well, just because that is a liquid that the students are dealing with. Students should obviously be directly supervised when using any of the equipment after they've met that first bullet. So they've been trained, they've been tested. I think everybody would recommend that test. Students should perform at 100% before they're allowed to use that piece of equipment. Include some safety questions on unit tests and quizzes, so you're always coming back to safety, regardless of the activity or the project or the unit that the students are working on. You can provide written and oral forms for safety and instruction and reminders. You can never have too many posters around the pieces of equipment too that help students identify pieces and parts and components and what to be looking for as they're using those. No open-toed shoes or flip-flops should be allowed in any lab or shop setting. And then tying back long hair, securing loose clothing and jewelry. I'll tell you a story, maybe I shouldn't, but my first year teaching, I took over an old metals lab and I was having students make little brass baseball bats on a metal lathe. And a student went over with a hoodie on, and those hoodie straps got wrapped around the spindle of that metal lathe. And luckily, I was nearby enough supervising those students, and I stopped the machine before that student was pulled in. But those straps were not breaking. Like he was doing everything he could to pull away, and he was losing that battle. So think about anything that's loose. A lot of students nowadays have to wear lanyards while they're in school, and so they need to tuck those into their shirt or just take them off during your class or whatever your policies are in your building.
The one,
Anything? Yep.
one thing I put in the chat. Okay, thank you. In the chat, I know session hosts put them in. There's a link to the science safety manual I put there. You can publicly access if you're interested in examples. And then Minnesota Department of Education has a really good CTE safety website. They just put out a new guide a couple years ago, and they have some safety policy briefs that they put out. And one is on occupancy load. And so there's examples out there. There's newer examples from states as they're seeing the value in safety and communicating this. There's newer guides coming out. And so if you're in a state where your guide is older, or you're making updates, or you're doing one for your district, there's examples out there that you can look at.
Yeah, and if you're not sure if you have any of these safety guidelines or protocols, reach out to your state department. Hopefully they can point you in the right direction, or maybe you could send them these other models and they could start to develop their own as well. So going back to some of the data, how many lab accidents occurred in the last 5 years? And you can see the red lines here are minor accidents that were either no medical attention, but they were documented, or just minor medical attention, whereas major accidents are in the purple bars there. So that's the Kentucky data you can see in the bar graph, and then in the box there is the national data. So just some data to show that accidents do happen. Kentucky luckily had 0 in a lot of those cases, but also, they did have 20 to 31 minor accidents there. And then you can see the national data as well.
Mark, would you say that, I know when we talked with some of the teachers at the workshop, some of them said that they had equipment stuff that they didn't know how to use, or they said that they felt uncomfortable using, so they weren't using it. Would you say that some of that, I know Kentucky was lower, which is good, but some of that may be because things weren't getting used to their full potential because people didn't have the safety training?
Yeah, and that was really the impetus of us bringing Tyler in to host that safety training. Is we had teachers that maybe a tech ed teacher retired, they were a science or a math teacher, and they were asked or told that they were going to take over this tech ed program. And so they were in a shop setting, but they didn't understand how the table saw worked or how you could change the belt on a belt sander. And so they just didn't have the kids utilize that equipment at all. And so really, and what we'll get into here in a minute is what that training looked like that we hosted. But really, it was the teachers using the equipment as a student, learning how to maintain those pieces of equipment, whether it comes to moving guards or adjusting settings or changing blades or belts. And so, yeah, I bet you're right, Tyler. I bet some of that is teachers would just not have the students using those shop tools because they weren't comfortable themselves, not only using it, but also teaching students how to use it.
And there's a study out of Australia, I think it was either Australia or the UK. I'm pretty sure it's Australia, where they found that they had a lot of out of content teachers teaching design and technology education. And what they found is that they weren't using the tools and equipment doing those experiential hands-on learning lessons as much. And they called it a watering down of the content because they weren't getting that hands-on application. And so their recommendations from that report from Australia were that our teachers need upskilling, is what they called it. And they said they need training, and we need to bring back that hands-on focus of the curriculum in design and technology education. So it's not just in the US, but we're seeing it in other countries as well.
Yeah, so here's kind of what Tyler was talking about. So factors that contribute to unsafe conditions or accidents. In Kentucky, you can see some of those factors were lack of safety training, inadequate equipment. So maybe the equipment was broken down and it wasn't usable, but also overcrowding, and then students failing to follow directions. You could see at both the state level and the national level was the number one reason. Um, and then you could see at the national level, it's very similar. Although the interesting one that comes out is number 4 for the national is the percentage of students with disabilities that are in those classes or in those labs and shops as well. Tyler, I may lean on you for this one just to talk about the various studies that have come about with some of this data on the screen.
Sure. So I'll breeze over this quickly so we can get to the what the workshop looked like. But essentially, we looked at, there have been some different studies you'll see dating back 2008. That was in science ed, and these were all just focused in Kentucky. And then the bottom one there's the national. But the big picture here being, if you look at the trends of safety over time from these studies, and this kind of goes to Ray's question earlier about, is this newer data? You know, when you look at some of the studies that have been done, safety has not seen significant improvements, to be honest. I mean, look at eye protection for all students. In 2008, the study found that 86% of teachers had eye protection for all their students. In 2022, we found only 83% of teachers did. So that should be 100%, especially in states like Maryland, where we have state statutes that say every occupant in a lab room or lab area is supposed to have eye protection and appropriate PPE on during the activities. And so that should be 100%. And if you think about PPE in terms of safety glasses, they're not super expensive, but they serve a huge purpose, right? So if you look at safety across the board, and this is in the journal article we have, sadly, it has not made the improvements that we'd like to see. So publishing this information and getting it out there and then providing the recommendations on how do you improve this is really important so that people can go back and say, hey, we need to make sure we put funding aside next year to get safety glasses for every student in the class. So we got to have 35 pair of safety glasses. So we have some extras so that when I have 25 students and a pair breaks, we're not waiting around for students to get safety glasses.
Yeah, so let's talk about the workshop that we hosted. So this was in 2021. We did a day and a half training. We hosted it at Eastern Kentucky University. We used one of their old wood shops. It's actually a crafts lab. A lot of old Powermatic tools that really can't be broken even if you wanted to. So we know that a lot of our programs were using, they were kind of an old traditional shop and then kind of transferring and using that equipment to teach engineering and the design process. And so we wanted to kind of mimic that. So we chose EKU's Crafts Lab and the equipment they had. And honestly, some of the reason that we chose it is some of their machines were actually broken down in that lab. So we could show teachers why it was unsafe to use these pieces of equipment. And then also walk them through how do you, like I've talked about earlier, how do you adjust the guards? How do you change the blade? What do you need to look for before the kids, start using the equipment each day? And so here you can see we had 8 females and 2 males came to this. The mean age was 42. The mean teaching experience was 13 years. 18% of those teachers had a tech ed certification. The other 82% were math or science certified. None of the teachers had received safety professional development within the last 3 years of this workshop. And 70% said they had not taught technology and engineering courses prior to the workshop that used hands and power tools. That, to Tyler's point earlier, it doesn't mean they didn't have them. That just means that they didn't use them in their program because they probably weren't comfortable or confident with them. So that kind of, made the reality of this workshop worthwhile, and all the work and time and effort that it took to put into this. And then just the box there on the side of your screen. Some of these teachers, 10%. So one of the teachers had no experience when it came to using tools prior to this workshop. A majority, 50%, had limited, and then 40% had moderate experience. So 4 of those teachers considered themselves moderately proficient or at least moderately experienced in using tools in a safety setting.
So some of the feedback we got too from the participants and just talking with them informally was they said, yeah, I know how to use like hand and power tools when I'm working at home, but it's different when I have to make sure I'm watching 24 students in a lab, right? So they understood that just because they were a project weekend warrior and they could do stuff at their house, it's a little bit different when you get into a classroom setting and now you're in charge of 24 middle schoolers running around and trying to make sure you're controlling the environment, right? So they understood that knowing how to do stuff as an adult on your own is a lot, and even coming from industry and having adults in industry is different than putting those people into a classroom and saying, here you go, supervise 24 students.
Yeah, so if you scan that QR code, it's going to take you to the Safer Makerspaces, Fab Labs, and STEM Labs guide that Dr. Ken Roy and Dr. Tyler Love here put together. So I'll let you kind of talk about that guide if you want, Tyler, and then we can go into like the agenda that how we ran the teachers through that.
Sure. So, I mean, there's a website with a preview of 2 book chapters there and gives you kind of the overview of the table of contents. So if you want to look at it, you can look at that. I think we just go right into the agenda to keep it moving.
Okay. So yeah, the things that we really focused on were actual safety issues that had happened, and then so teachers can understand how to minimize a reoccurring issue in their program. We talked a lot about the federal and state safety standards, like we've talked about on this call as well. What does liability and risk management look like? And then we actually use some case studies to kind of hammer that home for teachers to understand when they're liable, when they're not, how to minimize those risks. Talked a lot about the biological, chemical, and physical hazards. Again, going into safety practices, safer facility design considerations, and then where to find those additional safety resources, which we'll point you to as well.
Ironically, one of the things the teachers actually really like the case law activity, which usually is not a very popular one because it's kind of dry. It's like, here's the case, predict what happened, and then you look at what the ruling was.
Yeah.
But this group really found that interesting, which I thought was kind of an interesting result.
Yeah, so here was day one's agenda, just to give you an idea of how we structured this. We went through a mock accident form activity, and then like you can see there at 9:25, we went through the case law activity, gave a lot of feedback on or a lot of content on legal responsibilities and duty of care, went into professional practices, gave them a bathroom break, and then we went through we walked through the lab that we were going to use, analyzed, and had them actually do a safety inspection of the lab. So they actually walked through and did that as if it was their own lab to find and identify issues. Went through safety before lunch, first aid, and all that type of thing. And then after lunch, we came back. We went through design considerations when it comes to a lab. So we went through and looked at different pictures of labs, and had them think about maybe moving some equipment around, what was missing, where were the guards, did they have the floor taped off appropriately, where are the fire extinguishers and fire blankets and chemical showers and that sort of thing if applicable. And then we spent a lot of time just demoing the machines and then showing them those online safety tests that grade themselves and email the teacher the final score for the students. And we'll show you how to access that shortly. And then we actually had them start building and designing an activity because we wanted them using the machines, not very prescriptive, but in a way that their students would use that, so that we actually had them and I think we talked about that after the second day agenda that's coming up here in a minute. But they built ping pong ball launchers that were completely built out of wood with, they were actually launching ping pong balls into a bucket. But the goal was not who could hit the bucket the best or the most accurate or the farthest distance, but it was who could use the equipment in such a way that you understood how the sander worked and operated, the bandsaw, the table saw, the drill press. And we told them that they had to use these pieces of equipment in that lab in order to build it. So they couldn't just do everything with like a hand drill. They actually had to use the drill press learn how to safely and secure the piece of stock that they were working on and that sort of thing. Tyler,
We
you want to go through
also,
the second day agenda?
sure. I was going to say, we also, so we didn't just do read the rules, watch the video, take the test, right? That's like the standard traditional way to learn safety that probably a lot of people have learned in their schooling. We uh, demonstrated different ways to teach safety. So we did do that for one. And then for another, we did a backwards teaching example where we had them go out, watch us do how we used like a drill press, take some notes, and then we came back and discussed what they saw from their notes and then went through the safety precautions and then reiterated the demonstration. So we showed them different ways to present it to students to try to break up the monotony of it. And I think that's important too, is you want to give the teachers that pedagogical piece so that when they get out in the classroom, they're teaching it to students, you know, they know how to kind of mix up their instruction to keep them engaged. So day two, we had the parking lot when they came in to look for feedback. We looked at working with students of all abilities, inclusive makerspaces and STEM labs, where to find additional resources like safety tests and other information. We went through the project again just to reiterate things. And then we went over how to use a joiner, planer, and table saw and did demonstrations on those and had them take the test. And then we gave them a lot of time for project work. And then they cleaned up and shared out. We had some closing comments and we did a post survey that looked at their self-efficacy, if it had changed from the experience related to safety and using equipment.
Yeah, so here's just the design brief that we gave them when it came to that catapult. Again, that wasn't the intent of the training, but it was a way to get them to use all the pieces of equipment in the lab in a way that their students would. And then we built this out for them, like how to define the problem for the students, and kind of build a design brief. And we're not going to read through all this, but it goes into the solution requirements, what the students were supposed to do. You know, we were saying you would give them 15 days. That may be too many. It may not be enough, depending on your situation. And then here's just some pictures of the teachers, so you can see again, it was a very traditional lab that we were using a lot of Powermatic tools. But again, it was all about them using those tools in a safe way for them to take that information back to their students.
And I think one thing we'll add too is that when Mark and I sat down and we're planning this, we said, you know, we're going to have a lot of math and science teachers coming into this. And so what's an activity that we can do with them that they can really resonate with and relate to? And a lot of them, well, not a lot, some of them, I'd say probably less than half, maybe like 4 out of 10, said that they had done things with catapults or projectiles before, but they didn't build it from this sense, right? They might have had kits or different things. And so I think that helped with the buy-in. You got to know your audience and you got to know what their backgrounds are and what they're working with. And this really helped to get some buy-in from them because they could apply the physics, the math, and the science to this activity. And then they also did the hands-on piece with it as well. So they really got into it. I think some of the videos here Mark's going to show kind of express that excitement that they had.
Yeah, and I don't know if these will play or not through the Zoom, but this is just the teachers out practicing. And then I think there's another video here. Oh, there we go. And believe it or not, that's an adult, that's a teacher. She was super happy that she hit that, hit the bucket there for sure. Yeah, so this is just them at the end. Some of them worked in teams, some of them built theirs on their own. Again, the intent was not to hit the bucket, but to go through and use all of those pieces of equipment effectively. So Tyler, I'll let you go through some of the results that came out of that post survey.
Sure. So real quickly, we used a survey. There's a link there to an article that has the actual instrument questions, but it looks at one's self-efficacy. So in other words, Albert Bandura research says that if I have high self-efficacy and I believe strongly about something, then it has implications for my actions and how I perform in the classroom, right? So again, it's self-reported self-efficacy. There are limitations. But what we did find is that pre-survey, they were at 36.9 on all the questions added up. And then the post survey, the average was 49.8. So it went up 12 points, right? About 12 points. When we ran the analyses, there was a significant increase, statistically significant increase. Expected outcomes were more related to, those questions were related to how I would expect my students to perform. So if I'm teaching my students, I would expect them to operate more safely, or I could expect them to understand this or whatever, right? So self-efficacy was more internal for the teacher. Expected outcomes was more of my expectations for my students when they're doing hands-on STEM and tech ed. And so again, there was a significant increase there from pre to post. So that's good, right? That's good. That's what we would hope to see. But then we're going to get into here on the next slide. I think we did compare, this is from an article in Journal Safety Research that we did. And we compared the study we just talked about in Kentucky. We also compared a 1 hour online training that was done in Maryland. And then we compared the site number 2 was a half-day training with no lab activities, but it was an in-person training. But again, no lab activities. I was in Pennsylvania. Site 3 was the Kentucky one we just went over. And so you can see the differences there. When you look at the statistically significant increases in self-efficacy and expected outcomes between site 2 and 3, there were significant differences. So that half day versus 1.5 day, and the lab demo activities, letting them actually do the labs and test the equipment and be hands-on, that had a difference. The largest effect sizes were between sites 1 and 3. What was the difference? Well, you could say one was fully online, it was only an hour, whereas site 3 was in person, doing the demos, and it was almost 2 days, about 2 days long, right? So some takeaways from this are basically that, one, in person is key. I didn't realize that was difficult with COVID, and now everybody wants things online, but the in-person piece for the safety was really valuable. 2, demonstrating and having the teachers do the activity and then being there to assist them and help to build their self-efficacy. And 3, the length of the training. So I'm sure if we would have extrapolated this out and had it like 3 or 4 days, we may have even seen bigger increases, right? Because the more that they're doing, and if they did another project, they're starting to build more confidence in it. But moral story is, if you can do something in person, give them something hands-on to do, and make it so it's not just like a quick in and out training online, but it's going to be something where you're really good instructional practices, right? Like every lesson, you have your intros, you have your recaps, you're coming back and you're assessing, you're reiterating all those concepts from day to day and from unit to unit, right? Basically, that's what this is showing, is that the length of the training and the modality of the training made a difference.
Yeah, and Tyler, you want to go through this one as well?
Yep. So Phil Reed and Ferguson have a really good ITA article there that they also did this type of experience with teachers in Virginia, career and content switchers, and they give their view of it and recommendations. So that's a really good article. The big thing is research shows high quality safety training can have a positive impact, right? So the big national study with the 718 participants, we found that when the teachers that reported having safety training in their undergrad or grad experience, so some sort of college safety training experience, if they had also had safety training upon initial hiring by their school district, and if they also had safety training within the past 5 years as an update from their school system, they were 49% less likely to have had an accident. So if you think, we call it comprehensive safety training because it has multiple layers. If you think about that, you're reiterating new information and old information and having those discussions. That had a big impact. And then another study where we looked at the Mid-Atlantic region, and I see the 5 minutes, thank you. The other study at the Mid-Atlantic, that's a free article from the Journal of Technology Education. We found that teachers who went through a undergrad tech ed program and had safety training as part of their tech ed program in undergrad, traditionally trained, were 83% less likely to have had an accident, right? So safety training, I mean, that data shows that safety training is important. It shows that traditional training has its benefits, But for those that don't have a traditional program, that comprehensive safety training really plays a big factor. And so the big picture there at the bottom, that last bullet point is we want to keep hands-on instruction. We're not trying to scare people away. It's in the standards, the ITA standards, the STEL, right? It has making and doing. If you look in the standards, I think we did an analysis. It's like over 54 times, I think the word safe, safety, safer is used throughout the standards. It's not just one area where you check the box, but it's across the standards. And so that's another point to point out to your administration or your school district that safety affects everyone. And it's not just to check the box, but it needs to be considered in all that we do.
Yeah, so next steps, we followed up with teachers to see how their how what they learned during that workshop changed how they operated in their classroom. Were they more or less comfortable using the equipment or having the students use it? And then Tyler also had them implement the Kirkpatrick model. You want to talk about that at all, Tyler? Since I think we have 4 minutes left.
Yeah, so the Kirkpatrick model was actually a recommendation in our article from one of the reviewers. And basically we got to level 1 or perceptions,
Oh,
right? So level 2 would be testing their content knowledge through safety tests. Level 3 would be observing them and their applications and using safety in their actual daily teaching practices. And then level 4 would be what's the longitudinal effect over time. So obviously level 2, 3, and 4 takes a lot more time and resources, but that's really stepping up that investigation of safety to look at how. But if you're in a school system and you're a supervisor or you're a department chair, these are different levels that you can move toward and see how is safety, what's the impact of safety training, how's it being utilized.
Yeah, and then just here's our contact information if you want to follow up with us. I'll take them out to this website, Tyler, since we have about 3 minutes. Is there anything in the chat that we need to respond to?
I don't see anything right at this time.
Thank you, Steve. So yeah, this is just ITEA.org/safety. And here you'll find those resources that we've been talking about. So there's an entire safety site that you can go into. This was created by Dr. Tyler Love. But again, if you need content and resources about a belt sander, here's videos on how to use it. Then you can take the test. Basically takes them out to a Google form. And you just have them enter your email address as a teacher, and then it will email you the responses, but then they put in their name so you know who's submitting it, and then they can come through here and they can take this exam. Once they submit it, then you would receive the results. Again, I recommend 100% or not being able to use that equipment. So anyway, that's kind of what that looks like very briefly, but you can see all the tools that are on here. There's additional resources. There's resources specific for the teacher as well. And then here you can see that there's a free ebook all about safer engineering and CTE instruction that Dr. Ken Roy and Dr. Tyler Love has developed. So you can download that for free. And then it talks about those safety reports that we've been hammering on the whole time now. And then additional safety resources. So this is going to help you when it comes to overcrowding, when it comes to course enrollment size and how accidents go up, the more students. And then some other findings on here as well. Anything you want to add to close out on that, Tyler?
No, sorry, we took up the majority of the time. There's a lot of content there, but I'm happy to answer questions if people want to email them or whatever. I mean, the big thing that I try is just provide resources, right? There's a lot out there and you don't know about it until someone sends you the links and where it's at. So I'm happy if you have a question like, hey, where can I find resources on this? I'm happy to share if you have specific questions.
Well, gentlemen, you did a fantastic job on the safety side of things. The links are there, and also your emails are up on the board for everyone. I did want to ask one quick question. You need a quick answer. I really thought that the FTJ program through ITEA for the individual liability insurance at $100 was well worth it for $1 million worth of coverage. How do you guys feel about that? Is it a good thing, you think, on your end?
Oh,
Yes.
yeah. I think it's $108 annually. Does that sound right?
Okay. Yeah.
But yeah, it's very affordable and it gives you $1 million liability. You as a teacher, so if you're an ITA member, you can definitely take advantage of the liability insurance that comes along with that. Good point, Steve.
You got it.
And
All right.
I still have
Wonderful.
that. I still have that insurance policy, but I have it as the, they have like one for like if you have a small business or a trainer. So if you're in a school
Oh,
system
smart.
doing
Yeah.
training, there's like a step up. It's like $250 a year, I think.
Gotcha.
Well worth it. Well worth it.
All right, guys, I'm going to hit the stop stream and it'll take about another 10 to 12 seconds to